Something strange has entered our solar system. A long icy traveler from the stars, or something else. Could this be another interstellar visitor like Oumuamua, a natural comet from another sun, or an alien spacecraft silently passing through? In this video, we explore the mysteries of 3IATLAS, where it came from, what it's made of, and whether science can explain it, or if it might just be the most intriguing object we have ever seen from beyond our solar system. Normal comets orbit the sun, this one doesn't. 3IATLAS is moving on a hyperbolic orbit, meaning it's not bound by the sun's gravity it's passing through. Its eccentricity is more than one, just enough to confirm that it's interstellar. At discovery, it was about 5 astronomical units away, just beyond Jupiter's orbit, and moving at 60 km per second relative to the sun. Even the sun's pull can't slow it down enough to keep it here. Its incoming direction is near the constellation Lynx, and after 2025, it will leave toward Hydra, never to return. In space terms, this is a flyby from another solar system. This comet could be also at least 7 billion years old, older than our solar system. By October 2025, 3IATLAS will reach its perihelion, its closest point to the Sun, at about 1.4 AU in actually Mars orbit. From our perspective, it will not be seen here on Earth. For just a few weeks, the interstellar traveler will pass through the inner solar system, and scientists around the world are preparing to catch every photon it emits. When sunlight strikes it, frozen gases trapped inside will sublimate, forming a coma and a long whispering tale. A brief flare of beauty from something that's traveled for millions of years in darkness. Unlike asteroids, comets are fragile snowballs of dust and ice. 3IATLAS is estimated to be 300 meters wide, with a mass around 10 to the 9 kg, roughly 1 billion tons. Its density might be close to 500 kilograms per cubic meter, meaning it's porous, full of voids, a cosmic sponge. With the high speed and fragile structure, there is a real risk. It could fragment under the sun's heat, much like comet C2019Y4 did in 2020. If that happens, we might witness a spectacular disintegration, a final burst of light as it crumbles into dust. What is it made of? Early spectral models suggest a mix of water ice, carbon monoxide, carbon dioxide, and complex organics like other comets. But the ratio tells a different story. Scientists predict lower carbon to oxygen ratios and maybe a distinct isotropic fingerprints, hinting it formed under a cooler, redder star than our Sun. It might contain metallic traces, iron, magnesium, and nickel grains embedded in silicates similar to comet 67P, but aged by billions of years of cosmic radiation. Some of these metals might glow faintly in ultralight, giving the comet a bluish-green tail, typical of cyanide and diatomic carbon emissions. In that glow is chemistry not from our solar system, a literal sample of another planetary nursery. Every beam of light from 3IATLAS is a clue. When sunlight reflects off its dust, it becomes polarized. Its waves align in a particular direction. Astronomers will use this polarization to deduce the grain size, texture, and porosity of the dust. For 3IATLAS, predictions suggest an unusually high degree of polarization, similar to Oumuamua, meaning its dust could be fluffy and irregular, shaped by cosmic rays during its long interstellar drift. It's like reading the surface scars of an ancient traveler. As it nears the Sun, 3IATLAS will sprout a double tail, one made of dust, the other of ionized gas. But the ion tail won't stay still. It will pulse and twist, responding to the solar wind and magnetic fields of the Sun. Each pulse is a wave, a kind of heartbeat, revealing how the solar wind interacts with alien material. Through these patterns, scientists can study not just the comet, but how our solar system greets an interstellar guest. And of course, whenever something arises from beyond the stars, the question echoes, could it be artificial? When Oumuamua passed in 2017, its odd shape and acceleration sparked speculation, perhaps a light sail, perhaps a probe. So scientists are checking 3IATLAS carefully. They are monitoring for non-gravitational acceleration, reflectivity anomalies, and even radio signals across multiple wavelengths. So far, the data say natural. Its motion is driven by outgassing, not engines. Its light reflects like dusty rock, not metal. But in science, we look because we can, and when the answer is natural, it's still extraordinary, because every time an interstellar object passed by, it's a piece of another solar system, a cosmic messenger carrying the chemistry of a distant sun. Don't miss out. New videos drop every Sunday evening. Hit subscribe and ring the bell so you are the first to watch.